So hi everybody and welcome back to C++ tutorial series for absolute beginners. This is video 258 and in this video we continue with our virtual specifier. We stopped here at this paragraph and we will use this example now. Let's start. So first of all it says here base virtual function. This is, for example, in our case this one here, does not need to be accessible or visible to be overridden. So in our example here, we have here class B, and we know class B has by default a private access specifier if you are not specified here, and you can see it's not specified. That's why this one is private. We know this, and that means it is not accessible from the derived class, and you can see we have here a derived struct. It's not a class. You can see they mix here this one, and this is possible because we also learned struct and class are very similar. The only difference is access specifier and the constructor call a little bit, and there are some other little differences, but they are very similar, and that's why you can even mix this up and it works. That's also very important here to note. And then you can see this derived class will not have access to this one here. We know, we already learned this. All right. And then it says to be accessed or visible to be overridden, which means it still be considered that we can override it in our derived class. So for example, we have here our struct. You can see we have the same function here again. We learned this in our last video. There are some criteria like this one. If this is fulfilled, then we can override it. And they say here, it doesn't matter if it's private or inaccessible, you still override it. That's very important to note, because normally if it's private, not accessible, or you can't, or it's not visible, then normally you can't override it, or you can do something with it. But the compiler is doing this one here, not we. So as a programmer, and the compiler overrides this, which means it will be considered to be overridden. That's very important. Then let's go on. It says here base virtual function, this is this one in our case here, can be declared private. Here it is private. It's, yeah, we know it. Private, or base can be inherited using private inheritance. We already learned you can also make a inheritance private, which makes this virtual function again private. Inheritance. And then any members with the same name in a base class of derived which inherits base do no matter for overridden determination, even if they would hide base virtual function during name lookup. So which means this is the same thing what I just said. We have here derived class, we have here the same function, and as long as this is the case, it still be considered to be overridden. And we have not talked about this name lookup so in detail. This name lookup was mentioned here. There is a qualified name lookup, there is also an unqualified name lookup, and we have to go in this topic later on in one time. I don't know when, but it's important that we will watch this one too more in detail, but right now we concentrate on this one. All right, so that's it. Let's go and see what this example is doing, and let's see if we are going to understand it. Here it says private member. We already discovered this, but here it says public interface. Public interface in this case means just because this one is private, from outside we have no access. So you call this function here, and this function you can see has this do function here in its body, which means it's just an access function from outside, and that's why they call it public interface, because it's public. You can call it from outside this function here. And interface, this word interface is very important in C++, has different meanings in different situations. In this situation here it means just you have an access point. Do you create an access point from outside? But this interface keyword here is very important. We will talk about this in future a little bit more. And yeah, and then let's go here a little bit more, and here it says override. Again, this override here, I talked in my last video about this one, is optional, right? But a good practice is that you write this override all time. Why is this a good practice? Because if it says it's override, you can directly see when you read this struct, for example, this one is using virtual function call. This one is an override, and if this override is here, you know automatically there must be a function in the base class or any other class where it gets this function here, which is defined as virtual. So with other words, this override is an indicator for us. But here's the problem. This override is optional. We have discussed this in our last video. Optional means many people can avoid this. And we will talk here a little bit about the second example in a moment, and you can see they are not using override at all. And this is bad practice because now we don't know it exactly. So at least not with the first look. Then we don't know it, but with with the tooltip and so on, we still can find it out. So that's very important. For best practice, I would say we are using all-time override. And you can also see here, this one here is not declared as virtual, but we learned also in our last video, if the requirement is fulfilled, like this one has an invisible virtual here in front. Okay, so far so nice. And then let's go to the main and see how we create an object and use it and what happens. Okay, first of all, they create an object. It's called D. It is the derived object here. Yes, the naming is all-time bad in these examples, but it's okay. And then they are creating a pointer of the base. Very important now. This pointer is here pointing to D. And this is the new thing what we have here, because normally this one is not allowed. So if you make this with not derived classes, you will get an error. But here, if you make this with this, you don't get an error, and this is the new thing. What is here new actually? Why is this allowed? We will talk about this not now, but what happens here is an implicit cast. This one will implicit cast by the compiler. And we have already talked about the word implicit and explicit. Implicit means all time behind the scene, which the programmer can't see, but the compiler is doing it, and it's not good. Normally it's not good, but yeah, well, why I say it's not good? Because it's not visible and you have to know it. Explicit on the other side means it is formalized here, so you can here have a text which explicitly shows what the code is doing. So normally explicit is most time good, implicit most time bad, because we can't see it. You have to know it, you have to learn it. And in this case, here is an implicit cast. And this implicit cast here is a upcast. So there is a upcast and a downcast. We will talk about upcast and downcast also. And upcast means most time it is cause not so big problems because it's easier to do. But downcast, the other way around, will cause problems. And you have to make for example, this upcast here is implicit allowed by the C++ compiler because it causes most time not so many problems. But a downcast caused most time problems, and still it is allowed by C++, but then you have to make an explicit cast so that the programmer can be aware that he is doing a downcast. We will talk about this later, but just a little bit introduction, because if you don't understand this, you have to watch this online again, what means upcast, downcast, and then this one will be explained. We will talk about upcast and downcast too, but let's continue with these examples here. And then here, what happens here is we start with this object which was created here. So we created here this B object pointer. It is pointing to D, which is then still, what is the type after this cast? What do you think? The type is B. Why it's B? Because like I said, this one here will be casted. We talked about cast a little bit. If this is implicitly cast, this D, which is here a struct D type, will be casted to struct B, class B in this case. So that's very important. So in the end, this pointer is B, right? We are casting this here. So important here. What happens here is, now when we read this one, BP, it's BP here. This is our object. We are using this pointer notation because this is a pointer, so far we know, and we call F. right? This is the function we want call here, this one we call f. This is the function which we want call. So what happens then is here, we can already see this in the comment, internally calls d, which is this one, and then do f here. So the question is why it is calling internally d, because if we follow this one here, it's not here, right? It's not really here, but let's follow this again. B, we start here on top. This one is casted to the B, so I am B here on top. Then I'm calling the function f. This is my public interface, which means I can call it from outside, because you can see public. I can call this from outside, and this one indicates yes. I'm calling this one. This one is calling in his body d for f, so which means this is private because I can't access it from outside, but this one is now inside the class, so this one can call this one. All right, and important is now this one here, this function here is virtual. And what happens now is, let me show you a little thing here, because this one is also important to note, and what we have not shown here. What happens now here is, because this function is virtual, the compiler is doing again something behind our scenes. It is creating, and we will talk about this again in another video, it is creating so a called virtual table. And this virtual table, you can think about it, I make it not accurate, but just so that you get a little understanding. What the compiler is doing here, it says, okay, I create here a virtual table. Let's make this as a table. And a virtual table has this function. First time it reads this word virtual. Then the compiler said, okay, I found the first virtual function call here, and the virtual table here make a pointer exactly to this function, right? It makes here a pointer. So I know this is my start point. And this one, I said when in my other video, I mentioned there is a start point and an end point, and this virtual table makes it this way. I make the first time I see this virtual, I call this, let's see, this is our start point. This is start. Let's make it so, indicating this is our start point. And then the virtual table says, okay, and we will learn this a little bit more in detail down here with this override and so, but just here in this case also a little bit. And then the virtual table says, okay, is there another function which has the same name like this virtual function here? Which means, okay, we have here do f, so find I another function with the same name in the derived class. So here, this derived class is here. Oh, yes, I find one. This has the same name, and this one is also called, it's virtual here because it fulfills our requirements. We can't see it, that's bad, but we have to know this one is considered also virtual. And it says override. So this virtual table here says, let's point it here, the virtual table says, oh, I found in a derived class another function, and it says override. So this point, so let's say this pointer, the function here is written here, but it points here, and then it says in the derived class, oh, I find here but another one. I override this one what you have here. And what happens is, behind the scene, the compiler just cancels this pointer here and will use this one here, right? So this one. So what happens here, let's go now to our function here called. The function called here, by the way, this is not absolute accurate. When we talk about virtual, we make this accurate. But right now, let's see what happens here with this function call. This function call says, okay, I go to bf, I call this one. This one calls this one. So the compiler, this function here, this function is virtual. The compiler is creating this virtual table here. It starts here with a pointer to this one. But the compiler checks behind the scene if it finds another virtual function in the derived class. Yes, it is finding this one here. It is canceling this one. Canceling means it will not use this one here because the pointer, it's pointing now to this virtual function. And then it will use that. And how this works a little bit, we will read this here in the next section, in the next video, a little bit more in detail, how what's happening there, but not the virtual function. But then you can see this one is called instead of the top one, because this is an override, and the compiler checks all time the final override, because that must be not the last override. We will see if we have here even more derived classes which is overriding this function again, then the compiler would go even more down if it finds other override. But right now there is not another override. This is the final override. So important here is when you have this something here, that you realize there is the first time this virtual function, it will be our start point, and then the compiler will create a virtual table, and then it will just point out to the overrides if it finds in the derived class, and will use the last override it finds in the final section. And all this kind of stuff will be here. We will do in the next video again with this example here. But I hope you understand all this kind so far a little bit, and that's why it says here internally calls d so d is our d here, and then this do f, because normally what you would expect is, wait a minute, when you just read this one, you would normally expect without this virtual keyword it is just calling this one, and with because it's virtual, it's not the final override, it's just checking all the overrides in the derived classes. It finds this one and it will use that one. Okay, I think that was a little bit messy, but I hope you understand the basics a little bit. But don't worry, in the next example we make another override example. All this what I talked here will be explained here again more in detail. All right, with that said, I stop this video. See you in the next video, and if you have any questions like all time, write in the comment section. Have fun, bye, and good luck.